acoustic drape test on a fabric specimen results in a drape coefficient of 0.7. If the total mass of the paper ring is 3 gram, then the mass in gram of the paper with the shadowed area correct up to 1 decimal places. In this type of question, you need to notice that one answer is asked in 1 decimal place, so do take care of these units as well. So if you know the formula of drape coefficient, then in this type drape coefficient will be equals to mass of the shadowed area of paper upon total mass of paper. So the drape coefficient is given out to be 0.7, and the mass of the shadowed area, let shadowed area be x. So this comes out to be x, and then the total mass of the paper comes out to be 3. So x is equal to 3 into 0.7, that comes out to be 2.1, and it is also asked in 1 decimal place, so it is the answer. This is a 1 mark question. So these are simple questions. You just need to know what is drape. Drape is the hanging property. When a fabric hangs itself, it is known as drape. So and how drape coefficient is calculated? It is calculated on the weight of the total mass, so mass of the shadowed area upon the total mass. So it is a direct simple question. So you just need to take care of these types of things therein and thereafter. So now coming to the next question. If the moisture regain of polyester and cotton is 0.4% and 8.5% respectively, then the moisture regain of 70% polyester is to 30% cotton blend is in 2 decimal place. So it is a blend of 30s to 70s to 30 PC blend, polyester cotton blend. So moisture regain for polyester, it is given out to be 0.4%. So 0.4%, in place of percent we can divide it by 100, so it comes out to be 0.004. and for moisture regain for cotton, it comes out to be 8.5%, so it is 0.085. Since it is a blend of 70 is to 30, then the moisture regain of the blended fabric is, so whatever be the blend of polyester, so in case of polyester 70%, this is polyester, so 70 into moisture regain of polyester 0.004 plus 30%, it is cotton, so 30 into 0.085 upon total mass, it is 70 plus 30, it comes out to be 100 into 100%. So 100 to 100 cancel, and when you solve, it comes out to be 0.28 plus 2.55, and when you solve this, it comes out to be around 2.83%. so in 2 decimal place it becomes the answer. So it is also a 1 mark question. So these are simple questions. This is simple mathematics, so you just need to know the basics of textiles only. Now I think it will help you a lot in preparing for next year and to analyze your papers in a very good manner. So coming to the next question. So in this question it is written that match the properties listed in group 1 with the corresponding measure techniques given in group 2. The correct option is, so there are 4 options listed in group 1 and 4 options listed in group 2. You have to match them correctly based upon their functions and their role. So it is a 2 mark matching question. So this is a very simple question. If you know the basic functions, what SEM measures, what wide angle X-ray diffraction measures, what is the role of birefringence. So talking about P, crystallinity. So if you know crystallinity is measured by wide angle X-ray diffraction, it helps to find the amount of crystallinity percent in a total region, the amount of crystalline percent, and as well as the amount of amorphous percentage. So the correct option for P is third. And for thermal stability, TGA is used, thermal gravimetric analysis. So Q it is 1, and SEM, surface morphology, is measured by SEM, is scanning electron microscopy. It is used when you want to see in a microscopic level, micro nano level. So the surface, what kind of surface is there. If you have seen the surface morphology of different fibers such as cotton, jute, so it is measured by SEM. And birefringence orientation is measured by birefringence. So we get that for P it is 3, and for Q it is 1, and for R the correct option is 4, and for S the correct option is 2. 3142. So 3142, the correct option is option number B. So it is a 2-mark question. Coming to the next question. Now coming to the next question, this is also a 2-mark question from the 8 and regular sateen fabric can be woven with move numbers of 2 or 8, 1 or 7, 3 or 5, 4 or 6. For these you need to know what is basically a move number. And for 8 and sateen, 8 and, this is very important aspect of testing part, textile testing part, and what are the move numbers, 8 and sateen. So for a 8 and sateen, so how we decide the move numbers? So there are basic few rules for deciding a move number. First one is the move number cannot be 1 or equals to n, where n is the number of ends of a sateen, where here n is 8. And for a 5 end sateen, the n would be 5. So if we calculate for a 5 end sateen, the move number cannot be 1 or 5. So 1 or n, it could not be 1 or n where it is. And the second rule is move number can't be divisible by 2. Can't be divisible by 2. So option 2 cannot be, and option 8 is also wrong. Option 4 cannot be. So now there are two options left, B and C. The third rule is move number can't be n minus 1, cannot be n and cannot be n minus 1. So here for 8 it is n minus 1, it is 7. So move number cannot either be 7. So these are basic rules for deciding the move numbers of a woven fabric. So the move number cannot be 1, cannot be 2, can be 3, cannot be 4 since it is divisible by 2, can be 5, matlab it can be 5, and cannot be 6 since it is divisible by 2, cannot be 7 because it is n minus 1. So these cannot be the move number. So what is left is option number C, 3 or 5. So it is a 2-mark question. Option C is the correct option. Now coming to the next question. Now the next question that is given as the schematic of elastic recovery of a textile material is given below. This is the typical picture that is given here, where AB is the original length. So from here to here, this is original length of a typical fabric, and BD is the total extension, and when it is stretched, then it is the total stretch, and CD is the elastic extension. What is elastic extension? This one is the elastic extension, that is totally it is recovered from this to this. when it is extended, then it reaches to a D point, and when it is reaches to and comes back to the C point, but it does not recover 100% to the B point, and this one it does not recover, and it is known as permanent set. So with reference to these all these things, you have to answer some questions and match the following: P, Q are true, Q are true, and R is true, or P is true. You have to match them correctly. So it is given that with reference to the above schematic, consider the following statements. For elastic recovery, for perfectly elastic material, BC is 0. Matlab, for perfectly elastic means elasticity is 100%. 100% is recovered. So if 100% is recovered, BC would be 0, and it reaches to point D and then comes back to point B. There is no permanent set kind of thing in case of perfectly elastic. So it is a correct option. For perfectly elastic material, CD is equal to 0. For CD is equal to, CD means the elastic extension. If it is elastic, then the elastic extension cannot be 0. It is 0 for inelastic material where there is no elasticity or there is no extension. There, in that case, only CD can be 0, but in case of perfectly elastic, it is the elastic extension that cannot be 0. So Q is false. For perfectly plastic material, BC is equal to 0. If it is plastic, then BC cannot be 0, because if BC would be 0, then it would be 100% elastic material, where from point D to it reaches to point B only. So it is wrong. For perfectly plastic material, CD is 0. CD is 0. This is the elastic extension. For plastic material, there is no extension. Means the material cannot be extended. So elastic extension is 0. So S is true. So P and S are true. So option number D is the correct option. It is a 2-mark question. This is a basic conceptual question. If you know the basics of what is elasticity, what is elastic recovery of a textile material, then you can answer the questions easily. Now coming to the next question. It is a 2-mark question from textile testing part. So in this question it is said that consider the following statements with reference to the testing of cotton fiber in HVI. HVI is high volume instrument. High volume instrument. So based upon HVI, there are 4 options that is given. You need to find what are the true statements. These are multiple type of questions given in a single correct choice, because one and more options are correct in all these types of questions. So in these latest gate patterns, they ask based upon one or more type of multiple questions asked in single correct choices. So you should also focus on the what is the latest pattern of the gate examination. So the first option is strength is measured in single form. Second, strength is measured in fiber bundle form. Third one is fineness is measured by airflow method, and fineness is measured by measuring fiber diameter. So in case of HVI system, so these systems are based on fiber bundle testing form. That is, fiber bundle strength is measured in case of HVI. That is, many fibers are checked at the same time and their average value is determined. On which principle HVI is based on? HVI uses constant rate of elongation principle during the testing of the fiber samples. So option Q is correct. It is measured in fiber bundle form. And how the fiber fineness is measured? Fiber fineness is measured by airflow method. In this type, it is expressed in micronear value, and it is used for determining the fiber diameter using airflow method. So option Q and R are true. So option B is the correct answer. So this is a 2-mark question from textile testing part. Now coming to the next question, that is, it is also a NAT type of question. The tensile load F in Newton and elongation E in centimeter of a yarn are related as follows. F is equal to 2E square plus E. If the breaking elongation of the yarn is 10 centimeter and the work of rupture Newton meter of the yarn wounded off to two decimal places. The work of rupture is asked in Newton meter and the elongation is given in centimeter. So you should also focus on units, that the units, all units are in same dimensions. So if we write F is equal to 2E square plus E and breaking elongation is 10 centimeter, breaking elongation is 10 centimeter. So we know that work of rupture is area under force elongation curve. It is work of rupture. So the area under work force elongation curve, how it is will be written as, so it is will be written as area under curve. Area under curve is in represented by integration. So 0 to 10, the integration of 0 to 10 FDE. So we can write that as 0 to 10, in place of F we can write 2E square plus E times dE. So if we integrate this, so 2E cube upon 3, 0 से 10, then E square 0 से 10 upon 2. If we solve that, 2 upon 3, 10 cube minus 0 plus 1 upon 2, 10 square minus 0. If we solve all this, so then it will come out to be F is equal to 2 upon 3 times 1000 plus 1 upon 2 times 100. On solving this, it will come out to be 716.67 Newton centimeter, since dE is given in centimeter and the answer is asked in Newton meter. So in Newton meter divide by 100, then it will come out to be 7.16 Newton meter. And it is, since it is asked in two decimal place, then the correct option would be 7.16. It is the answer. I think you must have understood how the work of rupture is calculated. It is basically the area under curve, and how much the elongation is given, we can integrate easily using this simple mathematics and simple calculation. So I think you have understood the concept. Now coming to the next question. Under steady state thermal conditions, the temperature at various locations in a two-plate togometer is shown in the figure as given below. It is a two-plate togometer. If the thermal resistance of the standard bottom plate is 1.5 Kelvin per watt, then the thermal resistance K by W of the fabric specimen correct up to 1 decimal places. You have to find what is the thermal resistance. So using the induction formula, we can calculate this equation. If you know the induction formula, then Q is equal to lambda A T delta T upon D. This is a typical induction formula. Where Q is the heat measured in joule, lambda is the thermal conductivity, A is the area, T is the time, small d is the thickness, and delta T is the change in temperature. So taking all these things as constant, if we write as how these things are related, then we know that conductance is inversely proportional to 1 upon delta T. Okay, because lambda, conductance is lambda. So the relation between lambda and T, if we keep all these things as constant, then lambda and delta T, these are lambda delta T is constant. If we is equal to constant, then lambda is inversely proportional to 1 upon delta T. If we keep Q, D, A and T as constant, then this relation can be found out. If the relation between conductance and temperature is inversely proportional, then what will be the relation between T or resistance? Then resistance is directly proportional to delta T, since conductance and resistance is inversely proportional. So if it is inversely, then resistance is directly proportional. Then we can find that R is equal to K into delta T, K delta T. Then R is given out to be, R is 1.5. K you have to find thermal resistance and change in temperature. Change in temperature between T2 and T1. So 36.9 minus 36.4. 36.9 minus 36.4. So 1.5 is equal to K into 0.5. Then K comes out to be 3. So the value of thermal resistance of the fabric specimen in correct up to 1 decimal place is 3.0. You can write this as 3.0 K, value of K, but it is not the thermal resistance, it is a constant that we have seen. Now thermal resistance is R. So thermal resistance, how we will calculate R? Then R is equal to K delta T. Now again R is K, we have found out 3, and delta T is now difference between T3 and T2. 36.4 minus 34.8. 36.4 minus 34.8. 3 into 1.6, that comes out to be 4.8, and this is the value of thermal resistance, that is R, that is 4.8. It is 4.8 and it is the value of R. So the value of thermal resistance in K by W is 4.8. This is the correct answer. Now coming to the next question.